equation deals. So who remembers, let's go through this first one very slowly and carefully, then you can do the second one on your own more quickly if you want. But this first one, let's make sure we're all on board. What do we need to do first on this problem?
Make all the denominators
Make all the denominators the same. Now, this one is a little bit different, at least than the last couple in our notes, because there's nothing to factor. Normally, we would start out by factoring, right? But we didn't have to here. So we're going to make all the denominators the same, which means all the denominators have to have 3 parts. Don't they have to have a 3, an m minus, and an m plus? So this one needs a 3 and an m minus 2. This one needs a 3 and an m plus 2. And this one needs an m plus 2 and an m minus 2. Does everybody follow what's happening here? Scout?
Could we potentially, I mean, I don't know, but like, just do -3 instead of 3 times n minus 2? Why wouldn't we just do like -3? Because then that would make the n minus 2 and, well, on the first one we could do like in parentheses -3, multiply that by n plus 2, and then on the second one do +3, and on the third one do multiply it by -2. Does that make sense?
No. So I'm not, I would have to sit down and you would have to show me what you're talking about. It is totally wrong. Okay, not gonna work. It's not going to work. I'm not sure how to explain to you why it won't work because I'm not quite sure why you think it will. So here's the deal, Scout, and everybody else. I should have done it in different colors, but this original problem, this was an original denominator, this was an original denominator, and this was an original denominator, right? Those were my originals. They don't match. None of them match. They're all different from each other. They cannot be made to match. And I think that's what Scout's trying to do, is trying to make them match. You can't. The common denominator is going to be all 3 of those individual denominators multiplied together. Okay, I'm not going to multiply it out, but I have to have all 3 of them. Okay? Don't get tricky, do anything weird, because it'll be wrong. All 3 of those are your common denominator. So do you see how now they all have a 3, they all have an m minus 2, and they all have an m plus 2. That's the key. Are we good? As soon as that happens, as soon as they all have exactly the same stuff, then you can forget the denominators and look just at the numerators. Now remember, everything here is multiplied. So see that 3 times that 2? I'm going to go ahead and make that a 6 because it is multiplication. Minus 3m plus 2m minus 2, or no, m plus 2, m plus 2, they're both pluses, equals 7m plus 2, m minus 2. So look at that carefully and make sure that you agree that that's what's in the numerator. Okay, so what happens now? What do I do now? Now I'm going to start distributing. So 6m minus 12. Now this one is a lot. So I think I'm gonna do it in 2 stages, cause there's just a lot going on there. So I'm gonna go ahead and FOIL these 2 first. And then I'll times by 3 after I get it FOILed. So what do I get when I FOIL these 2? I get m squared plus 2m plus 2m plus 4. I'll come back and distribute that. And then here I'm gonna do the same thing. I'm gonna have my 7, now I'm gonna FOIL these. So that'll be m squared minus 2m plus 2n minus 4. Remember, when you distribute a -3, all the signs change. You may be doing things in a slightly different order than me, but hopefully you have come up with, well, wait a second. Can we clean this up a little bit? So, -3m squared minus 6m minus 24. Did anybody else get that on the left side? Olivia, you did? Okay. And then on the right side,
7m squared plus 20, yeah.
because these cancel. All right, so now what happens?
Subtract 7m squared minus 28 over.
You need to get everything on one side or the other, right? Now, again, everybody has his or her own personal style. I hate having my m squared be negative. So I'm actually gonna go that way. So I'm gonna add 3m squared. Does it matter? No. Go one way or the other. You gotta move everything to one side. So whatever you wanna move, move. I'm gonna add 3m squared over to here. I'm gonna add 6m over to here. And I'm gonna add 24 over to here. So that's what I got. Now, if you went the other way, you'll have -10m squared, -6m, and +4. It's the same equation. It doesn't matter. Hey, can I divide everything by 2?
Yes, you can.
So that might make, at least it'll make my numbers smaller. So 5m squared plus 3m minus 2. I'm thinking that might factor. Now, I totally get that I have a huge advantage. I'm 63, almost 64 years old. I've done this for how many eons? And I'm a math teacher, so I can factor that. What are you gonna do if you can't factor it? You're gonna use the quadratic formula. Now, factoring is always gonna be easier, but not everything factors. Or I should say easier, quicker. Not everything factors. So go ahead and use the formula if you want. This is how this one does factor though. So what would that make my answers?
And
7 equal to 0 and solving.
-1.
So one of them's gonna be -1 and the other one's gonna be 2/5. Now, I want you to look. Sometimes we throw these answers out. Do you remember yesterday? Not this time. because the only bad answers would be -2. -2 would be bad. +2 would be bad. And that's it. Those are the only two bad answers. I didn't get those, so this is the answer to the question. Both of them.
It's only extraneous if it's on the left side of the equal sign.
If it
So
makes
like,
a
'cause 3 is not.
zero in any denominator,
0 and 8 denominator.
in
Got it.
any denominator,
Thank you.
that denominator is 3, period. I don't need to worry about it because it doesn't have a variable. 2 would make this 0, -2 would make this 0.
So no matter what side of the equal
Doesn't
sign it's
matter.
on, just as long as it makes 0.
Denominator cannot be 0 anywhere, anytime, any place. No denominators can be 0. Okay? All right, let's turn it over. There's another one on the back side. Now remember, when you start putting things, trying to make your denominators the same, these are unbreakable. These are quantities that can't be broken apart. So, doesn't this one need a 2x plus 3? This one needs a 2x plus 1. And this guy needs them both. All of your denominators have to match. All of them. This is a 1. He needs to be 2x plus 1, 2x plus 3. So here we go. This one's going to get times by 2x plus 3. This one's going to get times by 2x plus 1. And this guy gets them both. Got it? Everybody's clear on step 1. Because now it's just a matter of solving. Now we can get rid of the denominators and just look at the top. Take a look at that. It's kind of a big, long equation. Does that make sense to you? Does that look like what you have? Okay, so what do we do?
Distribute.
Yeah, so I'm gonna do a busily writing already. We're gonna distribute. I want you to be careful here. This is gonna be 8x squared plus 12x, right? Now watch this. Be careful. See that negative? That gets times by both of these. So this is gonna be minus 4x squared minus 2x. Now it's easy when I'm up here talking you through it. You have to recognize that. Negative 2x times 2x, negative 2x times 1. And then we'll FOIL over here first, outside, inside. What a mess. It would probably be easier to clean up each side first, would you agree? So let's clean up over here. So that's gonna be 4x squared plus 10x.
Yep.
And then equals 4x squared plus 8x plus 3.
Yeah, X to one.
Move everything to one side. What's gonna happen, it doesn't matter which side you go here, what's gonna happen when I move this 4x squared over here? They're gonna cancel, aren't they? I'm gonna subtract it over. Then when I subtract my 8x, I'm gonna get 2x. Minus 3 equals 0. Is that okay? So 2x equals 3 and x equals 3 halves. And my radar aren't going up, but I checked to make sure. If I put in a positive 3 halves, that will not be 0, right? And this will not be 0. So I don't need to worry about it. I only worry about it if it makes a 0. Now, the timing of this just stinks. When do I see you again? Monday. So we'll have a little quiz over this. It'll be only one problem. We have two paper, but only one problem over this. Okay? On Monday. We have office hours tomorrow, we have office hours on Monday. But we are moving on, to do some other stuff too, okay? Alright, so we got that now, we know what we're doing there, let's get our notes out. Alright, so here we go. One problem quiz over 2-7 on Monday. Please don't forget, you guys, please, please, please. All right, here we go. We are back in our notes now. At the end of the period, I'm gonna hand back your quizzes, but right now, we're gonna take some notes. All right, so here we are on page 22, we're ready for number 4. We talked about these last time, but if you look at the ones we did last time, you remember, look at them there, they're all factored already. See how they're all in parentheses? It's all perfect. What do we need the parentheses for? To figure out where to put the dots on our number line, right? Whenever we see a symbol like this, we're gonna use a number line. And the factors tell me where to put the dots on the number line. So what do you think I'm gonna do first on this problem? Factor it. And just like the graphing you did, kids, is it important to get the right factors?
Yes.
Yeah, because your factors are gonna give you your dots. Wrong factors mean wrong dots, which means wrong answer, right? So, let's get it factored correctly. How does this one factor? This is an easy one. X
It's plus 1 minus 4.
plus 4 minus 1. So here's my number line. Where are the dots gonna go? At -4 and +1. Do be sure you put these on the right order. You know, this is a number line. So like there's a 0 right here. Make sure you get them oriented correctly toward each other. All right, open dots, yep. Now I gotta figure out where I'm shading. So what do you think? What should I do? How would I know?
Check numbers.
Try 5? 5's your favorite number? So he says try 5. 5's out here. Pick whatever number you want, except these two. But pay attention to where it is, because that's what I'm trying to figure out now. Am I gonna shade over here now? So 5 plus 4 is 9. 5 minus 1 is 4. If I multiply 9 times 4, does it turn out bigger than 0?
Yes.
Yes. shading. Now, if you want to try other numbers, you always can. But this problem is what we call a normal problem. And in a normal problem, when there aren't any powers on these, when it's just a factor times a factor, the shading always alternates. Remember that? So you can shortcut this problem if you wish. Since I shaded there, I won't shade here, but I will shade here. When you have plain factors, no powers, no squares, or cubes, or anything, then you can go every other one with the shading. Remember that from before? We're not gonna be able to do it on every problem, but we can do it on this one, because we don't have any we don't have any of this. This would cause me problems. So what's my answer? Negative infinity to negative 4, parentheses, union 1 to infinity.
I completely blanked on the part where you had the -4 shading the other way. Does it just shade the other way because you already have the 1 shading that way?
Shaded, not shaded, shaded. But Jude, if that's gonna confuse you, pick a number like 0, see if it works. Pick a number like -5, see if it works. You can always get the answer that way. All right, how about the next one? What are you gonna do first with this guy?
Factor.
Yep, and again, it's a pretty simple one, I think, to factor. What are our factors for this? -3, -4. So where will the dots go on my number line? +3, +4.
Closed dots.
Closed dots, which means when I come over here to write my answer, I won't be using the parentheses, I'll be using brackets. Okay, but I gotta figure out where I'm shading, so pick a number, any number except 3 and 4.
5.
5. So again, we're out here, we're picking 5. 5 minus 3 is 2. 5 minus 4 is 1. Remember, you're multiplying. 2 times 1 is greater than 0. So we're gonna shade this. Again, this is a perfectly normal problem. So if I want a shortcut, I can say, okay, I'm not gonna shade here, but I am gonna shade here. So negative infinity to 3. Infinities always have parentheses. And then 4 to infinity. We did these earlier in the year, those exact problems. Now we're gonna do some harder ones now. No yawning allowed. It's only Thursday, we still have one period to go. Now, Michael's got the, I don't know if it's good or bad fortune of sitting right in front of me, so I can watch what she's doing. So the first thing she's doing is this. Now, I'm telling you right now, that is an excellent thing to think about, but it's not gonna work, is it? Remember, if you do this, it's called factoring by grouping, you have to take out something. So here, well, actually, that wouldn't go there, but you can take out an x squared and be left with x minus 2. But when I factor over here, am I gonna be left with an x minus 2? So that means it's not going to work. Oh boy. What do I do when factoring factoring by grouping doesn't work. No, I can't do the quadratic formula. Synthetic division. I'm gonna do my PRRs and I'm gonna do synthetic division. I have to factor this. So, my PRRs are 1, 2, 3, and 6, plus or minus, over 1. So what do you wanna try? 3? Wait, I can only try one thing at a time. And actually, I think that was a great pick. 3? So what are we doing here, folks? We are flat out guessing. We guess a number, we do the division, we hope like heck we get a 0. If we don't get a 0, we guess another number. But if we do get a 0, we now know that I have a dot, I don't know where 3 is on here, but I have a dot at 3. That number is my dot, which means my factor is x minus 3. Take a minute and digest that. Now there gotta be 2 more factors here. How do I know that? X cubed. Where are the other 2 factors going to come from? The numbers on the bottom, we call it the quotient right here. So that's gonna be x squared plus x minus 2. How does that factor? Minus 1 plus 2. So this right here factors. So I have my original factor that I guessed, and then now I have these 2 that come from factoring the part that's left. So here are my factors. So now I'm gonna go back to my number line, and there are going to be 3 dots on the number line. And where will those dots be? 3, -2, and 1. In that order now. This is a number line, so put them on there where they belong. They will be closed dots. This is a normal problem. Think of it in the graphs we did on the last test. Is there gonna be bouncing around in this one?
No.
If there's no bouncing, it's normal. Okay, so this is a normal problem. So I just need to figure out one section. So what number do you wanna try?
-1.
-1. If you try, why would you try a negative number? If you wanna try a -1, that's fine, but it's in here, right? This is where it is. So -1 would give me -4 times -2 times 1. You know, you give Lisa 4 to pick, she's gonna pick 0 every time. Because I'm lazy, and that's the easiest number to work with, right? I'm sure as heck never picking a negative number. But whatever, it works, it's fine. -4, -2, and 1. What do you get when you multiply those? This is a
-8.
multiply. What do you get? You get 8. Is 8 less than 0? No. So what does that mean? That means this is not shaded. Which means this one is, and this one is, and this one isn't. So my answer is -infinity to -2, or 1 to 3. There's a lot going on in that problem, guys. How are we? Well, looks like we got another one. All right, here we go. Is this one also going to have 3 parentheses? Yep, because it's an x cubed, kids. So it's gonna have 3. So I need to figure out what they are, and then figure out where to shade. So, Scott, you had your hand up. Did you have your hand up for a reason?
I was wondering if we could do like grouping this one.
Oh. You think this one might group? It looks very promising, doesn't it?
Oh, yeah.
Because in the first 2, we can take out an x squared, and we will be left with x plus 3. What can we take out in the last 2? Negative 4, and we'll be left with x plus 3. That's all good now, right? That's good. So x plus 3, and then x squared minus 4. What about x squared minus 4? That's the difference of squares, x plus 2, x minus 2. What?
Say if you can factor, it's not easy.
Yeah, if you can factor, it's not bad. Okay, factor by grouping, you
Too
mean?
shabby.
Yeah. All right, so where are my dots gonna be?
-3, -2, and 2.
-3, -2, and 2 in that order. Open or closed? Open. Now, do we have any weirdness in this problem? Nope. So I just need to pick one section. Please don't pick a negative.
Oh,
0. Person after my own heart back there. Let's pick 0. Keep in mind, 0 is here. So 3 times 2 times -2. I put in 0. I have 3 times 2 times -2. Is that number, whatever it is, bigger than 0? No. Which means this is not shaded. Which means this is, and this is, and that isn't. So this time, I'm -3, -2, and 2 to infinity. Now, I bet there's somebody in this room that's thinking, how do they know that factors by grouping? So that person isn't going to factor by grouping because he or she doesn't recognize that it does factor by grouping. Could that person do the guess and check and division method with this guy? Absolutely. You can always do that. It's like the quadratic formula. You can always do it. It may not be your fastest method, but it will always work. Okay, we good with that? All right, now, number 8, we're gonna do one of these and then I'll pass your quizzes back. Number 8. This one looks different, doesn't it? Actually, we may do 2 of these. Maybe both of these. All right, this one looks different. Our last problems, the parentheses were like written sideways, right? Times each other. This one is a division. That does not change your overall strategy. two dots on the number line. Take a guess where those two dots are. -1 and +3. So the fact that the problem is stacked doesn't change the way you at least start, right? Are there any squares in this problem or anything to make it weird? Nope. So pick a number somewhere. 0. Now zero's in here. If you pick 0, you're gonna have 1 over -3. This time it's a division, not a times. 1 over -3. Is that less than 0?
Yes.
Shaded. And if that one's shaded, this one's not, and that one's not, so the answer is -1, 3.
That's.
Easy as pie.
Yeah, easy peasy lemon squeezy.
Gotta factor it first. That's a common theme. We factor. So x plus 3, x minus 3, x plus 2, x minus 2. Now, if something cancels, then you definitely want to cancel it, but nothing cancels. Would you agree? Yeah, so nothing's gonna cancel. Here's my number line. How many dots am I gonna have this time? 4.
Oh.
I'm gonna have 4 dots. And the dots are gonna be at -3 and 3, and -2 and 2. Would everybody agree with that?
Yeah.
Now, there's a lot of dots, but that doesn't change anything. There's no squares on any of these. So when I figure it out, I'm gonna be going every other one. Shading, I mean, every other one. I just need to figure out something. So, I don't care what you use to start with. I'm gonna use 0. 0's right here. So I'm gonna put a 0 in. And I get 3 times -3 over 2 times -2. Would that's gonna end up being -9 over -4, which is 9/4. Is 9/4 bigger than 0?
Yes.
So that means where the 0 is, I'm going to shade, which means that is not, but this is. That is not, but this is. Now there's one thing that I probably need to manage here before we write our answer. What do you still think I need to take care of?
The
Greater
shaded-
than.
the shaded
Are the
circles.
dots
Shaded.
shaded or
Those
open,
circles.
right?
Shaded.
Okay, here comes the trickiness. I know, you were waiting for the other shoe to fall. Court's going like this. You're waiting for the other shoe to fall here. If I shade in the dots, then that means that x can be -3, -2, 2, and 3. And I want you to look at your problem. There's nothing wrong with x being -3, because you're allowed to have zeros in the numerator. You cannot have zeros in your denominator. So even though it looks like I should color in all the dots, I can't color in the -2, and I can't color in the 2, because that would make my denominator 0, right? I can color in the numerator dots. So what I always tell the kids, to try to make this manageable for you, because that is tricky. Denominator dots are always open. I don't care what the symbol is in the problem. If it's a dot coming from the denominator, so that would be -2 and 2. Coming from the denominator, it's open, period. The numerator dots follow the symbol in the problem. Denominator dots are special, and they are always open. All right, let's write our answer. What's our answer look like?
Parentheses, negative infinity, comma, -3, bracket, union, parentheses, -2, comma, 2, parentheses, union, bracket, 3, comma, infinity, parentheses.
All right, how'd the birthday girl do? Birthday girl yesterday, she's 18 now. How'd that go?
I think that went pretty strong.
Does that look all right?
Scouts yesterday, you got that, the bonus rounds.
I needed that, thanks to that.
Big bonus, you got the bonus rounds. That was lit.
Big bonus.
That, yeah.
The bonus rounds.
Are we good with that, folks?
Very good.
All right, we're gonna pause there.
16 out of 20.
Come on. What happens on Monday?
Quiz.
We have a quiz. I've lost track of, might have homework due that day too. Let's see, no, you have homework due tomorrow.
Which one?
2.7, we haven't finished.
Okay, I've already.
Okay, so now I wanna get back your quizzes. I want you to find somebody